Presented here are these pigs. There's a small one there, that's larger, and that's about the same size as that one. Now these are weaner pigs. The disease occurred on a deep litter system in a single piggery in Brisbane. And I will allude to the deep litter system later because I think it was part of the cause. So what I'm pointing out here to you is that these are weaner pigs. That's an early weaner. That is a pig of about 4 weeks, and that's about 8 weeks. So you can see that the disease has a range. It occurs in weaner pigs on a deep litter system in a single piggery in Brisbane, Australia. From that comes a long journey of discovery, which ends by looking at the subcellular organelles of the tissues, the nervous tissues, under the electron microscope in order to discover the real neuropathogenesis of this disease. And from that evolves a new concept about neuropathogenesis which can be applied to many diseases of the nervous system of both man and animal. Now, before proceeding to the specific neurological clinical examination, I will mention the diagnostic possibilities and the differential diagnosis associated with routine clinical medicine. Now, we're faced here with pigs that are showing locomotory disturbances. Locomotory disturbances can be divided into 2 main parts. One is neurological disturbances and the other is lameness. Now, I think we will very quickly rule out lameness. So we're left with neurological disturbances. So there are quite a number of etiological agents associated with neurological disturbances. We further divide these neurological disturbances into 2 parts, infectious and non-infectious. We get a lead into that, solving that mystery, by the clinical examination for body temperature. So if we find that the pigs have a fever, then that will tend to rule in infectious diseases and rule out non-infectious diseases. Now, the non-infectious diseases that come to mind could be arsenic poisoning and a number of other drugs, other chemicals. It could be of congenital origin. From time to time at piggeries, there's a condition called salt poisoning. This arises because the pigs are deprived of water, and when they're given the water again, this produces a typical series of nervous signs in which they go into epileptic-like fits at specified times, and then they recover. That's another one of the diagnostic possibilities, and this can be ruled out because of these clinical signs and the history of water deprivation and the histopathology, where there's eosinophils quite frequently in the meninges in particular. Sometimes another lesion is seen, which is, when it is seen, it's characteristic, and it's known as laminar subcortical polioencephalomyelacia. Myelacia, of course, means softening and necrosis of that particular area of the brain. Once we've ruled those out, we can then rule in infection. Now, as far as infections are concerned, it could be viruses, it could be bacteria, and another disease which is part of the differential diagnosis and diagnostic possibilities is streptococcal meningitis. Can be ruled out by histopathology, and in which and by microbiology, where the streptococci are isolated, but under the microscope, histopathology, one sees neutrophils rather than mononuclear cells that you see in typical viral infections. It could be fungi, could be protozoan, maybe even the famous prion, which is now very popular in the literature, but in many ways misunderstood or not understood. So I will attempt systematically by ruling out and ruling in the various possible diagnoses to reach a pathological diagnosis and an etiological diagnosis. So, as well as pursuing the topographical mapping, I studied the diagnostic histopathology, and by doing that I was able to identify and separate out the various infectious diseases. By studying that, you can get an idea of what the actual etiological agent is, and I'll pursue that later. So, the diagnostic histopathology revealed new and original discoveries, which I'll allude to later. So now I'll turn to the clinical examination, the neurological examination of these pigs. These animals have been looked at to see the nature of the locomotory disturbance. They can stand. But when they stand, you'll notice a crossing over of the hind legs, which is an indicator of posterior ataxia or paresis. There's a certain weakness, we call it paresis. You might call it ataxia. So all of these animals showed this evidence when they could stand, but some couldn't stand. Some of them were paralysed, just like the highly virulent Teschen disease. And so one wonders immediately about the two-strain theory, because you've got one virus producing a range of neurological disturbances which one might establish that there's some sort of immune differences between them. So these animals are looked at from a point of view of writing, ability to write, their body to re-establish themselves, and we can see that they can basically do that. They're aware of their surroundings, they're bright and alert. Now this is a hyperesthesia, and this indicates that there are lesions in the spinal cord. Now for hyperesthesia, this certainly indicates that there's spinal cord lesions there. So once again we proceed, we can see that basically the pigs can show various evidence of, see how they can take the weight on their front legs. They're still rather weak on the front legs, but they can take more weight there than before. We will see later in the histopathology that there are actually lesions in this upper part of the spinal cord, as well as lesions down here in the lower part. So it's an overall paresis, hind leg paresis, involving the front legs as well, but to lesser extent. So all of these animals have been given a routine neurological examination of the same nature. Pig 5, similar, can take the weight on the front legs, on the back legs, less so. Ataxia means errors in rate, range, direction and force of movement. So these animals are showing evidence of rate, range, force and direction of movement, which is ataxia. So they're all pretty similar, except that some are more severely affected than others, and some are actually paralysed and can't move at all. So this was the range of nervous signs that we saw, and stimulated thought as to the fact that we're dealing with one agent but a range of neurological disturbances, which from logical deduction means that there's a range of immune response. So here's another pig on day 8, which still showing these disturbances, locomotory disturbances. The pigs again are bright, alert and aware of their surroundings. It's taking weight on the front legs, the hind legs are weak and the tail is not curly. It's a little bit curly there, but not as curly as the curly tail you would expect. So this is at day 8 from this particular pig that was observed for 8 days. I've used this title, Epidemiology, in quite a general sense by combining clinical medicine per se with conventional epidemiology per se. I think it's natural that they should be combined, so I've done so. For this paper, there is a multidisciplinary approach. Various subjects or disciplines which I will present follow now. They include case definition, diagnostic possibilities, differential diagnosis, tentative diagnosis, post-mortem examination, sampling, gross pathology, histopathology, and histopathology includes topographical mapping of brains, both quantitatively and qualitatively. Then on to clinical pathology, hematology, serology, microbiology, including bacteriology and virology. So that's the sum of the multi-skills that I will look at. And the clinical examination also will include aspects of neuroscience and things like pain. One of the discoveries that I made, not just in this first paper, but a series of papers that evolved from that first paper, was the connotation that the current two-strained virus hypothesis called Feteschen-Taufen disease is a myth and is to be falsified. The hypothesis arose from my first examination of the natural outbreak, and I developed certain hypotheses as a result of that, and I obtained much stronger evidence by experimental research, inoculating pigs with normal virus and with an immunosuppressive called cyclophosphamide in another group. So what has developed is what Kuhn described as a structure of the scientific revolution, which he published in 1962, in which he referred to new paradigm shifts and the fact that the scientific revolution is a series of spasmodic episodes without continuity as such. My research has developed by obtaining empirical evidence and building on that, using hypotheses. From out of that came new paradigm shifts, and eventually at the end of my experimental work, the development of a general theory on the neuropathogenesis of this virus and other similar viruses that may or may not attack the blood capillary cells in the brain. I now turn to concepts of disease occurrence. A critical premise of epidemiology is that disease and other health events do not occur randomly in a population, but are more likely to occur in some members of the population than others because of risk factors that may not be distributed randomly in the population. One important use of epidemiology is to identify the factors that place some members at greater risk than others. Turning to causation, a number of models of disease causation have been proposed. Among the simplest of these is the epidemiologic triad or triangle, the traditional model for infectious disease. The triad consists of an external agent, a susceptible host, and an environment that brings the host and the agent together in this interplay of forces. In this model, disease results from the interaction between the agent and the susceptible host in an environment that supports transmission of the agent from a source to that host. In looking at past research on epidemiology, it's most unfortunate that the many research workers did not apply the basic principles of epidemiology to their research. Very simple, the triad. By applying these basic principles to the research, a lot more information can be gained and was gained by me in doing this. If they had applied these principles, a lot more scientific evidence would have been forthcoming. There really would be no need for me to stand up here now and talk about it, because the confusion started 58 odd years ago, when instead of calling the particular disease at the time a form of Tesha disease, they called it Talfin disease. My particular goal or plan was not really to examine this aspect. My particular goal is looking at neuropathogenesis of this particular disease as a pathologist, an epidemiologist. But as the evidence unfolded, it became quite clear this idea of there being two virulent strains, one highly virulent and one mild, one highly virulent called Teshin disease and one mild called Talfin disease, was a myth to be falsified by empirical evidence, not by dreaming, but by empirical evidence. So this actually unfolded as I was studying neuropathogenesis. So that's why it's so important to look at the agent and the host and the environment all together, because there's an interplay of those things all together. Turning to the history of Teschen-Talfen disease. Teschen disease, or a disease similar to it, was actually reported in Poland in 1910s, 12s, but it was officially documented across the river from Poland at a town called Tessen, T-E-S-I-N, and the German for Tessen is Teschen. So Teschen disease got its name from Tessen, and in 1930 it was described by Trefny, and then the pathology and clinical aspects was described by Kloberg in 1931, who did a lot of work, and in fact that disease is currently in Czechoslovakia called Kloberg's disease. That particular disease was characterised by high mortality and morbidity. That is, very high number of deaths, nervous signs. Now, it took some, 20 odd years later before the virus was actually isolated on tissue culture in 1955 by Lasky. He made the first, it was about 25 years later, as I said, he isolated the virus. In 1955, a disease occurred in Denmark, was described by Ben Dixon and Sijolti, and called enzootic transmission, an enzootic transmissible poliomyelitis of a milder form. No isolations were made of any virus, and in 1959, again in Denmark, Thordal Christensen described a disease called benign enzootic paresis, which also was of milder form. Again, the virus was not isolated. In Wales, United Kingdom, a disease similar to that of the Danish types was described. And instead of calling it the same names as the Danes, they decided to call it another name, called Talfen. Talfen was the name of a hill in Wales, so it's called Talfan disease. So therefore we have a situation where we've got a highly virulent disease and these other diseases in which the virus was not isolated, and therefore it's understandable that they might think they're totally different diseases. However, in the early 1960s, Huck and others isolated the Teschen disease virus from Talfen disease outbreaks. In other words, they isolated the same virus that was isolated from the severe clinical form in Poland and then in Czechoslovakia. And in fact, Huck and others showed that there was cross-neutralisation between Talfan and Teschen. Since that time, nobody has shown that there's any molecular biological difference, no genomic difference, between those two viruses. So a little bit of simple logical deduction in the past might have led them to believe that some other factors are working. If they had a basic understanding and appreciation of epidemiology, they would have seen that there could be an interaction between the host, the agent, and the environment to produce those differences in virulence. So it's taken until now, with this presentation and my publication, to actually show that those two viruses are one and the same. That there's no such thing as a two-strain virulent Teschen virus. So what's happening? Very easy, with a little bit of simple deduction, that there's a difference in the immune status of the host. And so what I did, what evolved in my first experiment on the natural outbreak, was to classify the cases according to severity. When I looked at this, it became obvious to me that some of those pigs were showing the clinical manifestations of Teschen disease. Okay, there was not a high mortality that we observed before by Trefny and in Czechoslovakia, Madagascar and certain other places. And more recently in Haiti, Teschen type of disease has occurred. So the explanation that I'm putting forward is that there's a variation in the immune status of the pigs, which, unrelated to the virus, it's exactly the same virus and the immune status is different. Now, I classified the case population into various stages of severity, which I'll show you. And as I said, the mortality was not high. In fact, only one pig died. But in my opinion, the death of one human being or the death of an animal is the ultimate test of virulence. Who can argue with that? The other aspect is that those animals, the more severe ones, were non-ambulatory. Isn't that a test of virulence? If an animal or a human being cannot get up and remains paralysed, is that considered mildly virulent? I don't think so. So there we have a situation in which this arose from my observations in the natural outbreak, which made me suspicious that there was only one virus. Later on, I provided much stronger evidence by immunosuppressing one group, using the mild virus and reproducing classical Teschen disease that they all saw in Czechoslovakia, Madagascar, and more recently, in the last, in 2012, in Haiti. So what's going on? I induced a classical Teschen disease with an immunosuppressive. So then the thought processes were, are there any natural immunosuppressives? And of course there are. It's well documented now. Circoviruses and other viruses can immunosuppress to produce these diseases. Some suggestion of so-called retrovirus of pigs, which is rather considered to be not pathogenic, but it could interact with other viruses at the time. So I'm suggesting that there is a concurrent occurrence of these other immunosuppressive type viral agents which exacerbate the disease and produce a Teschen-like disease. When the disease first occurred in the 1930s, there was no virus isolated at all. So there could have been a lot of viruses there at the time. They didn't even isolate Teschen disease till 1955. So therefore, there is quite a high probability that there were other viruses at that time producing the more elaborate, the more severe type of disease. And that's my hypothesis. So now we turn to one of the fundamental aspects of epidemiology. And unfortunately, the fundamental aspect of epidemiology in the past has not been attended to. What I'm talking about is case definition. And as I said before, by examining the range of severity, I was able to come up with the concept that the virus of Teschen and the virus of Talfin was exactly the same. I then produced experimental evidence that virtually confirmed that situation. So here I'm going to show you how I grouped these various cases into 3 subgroups of that particular disease characterised by neurological disturbances. During that natural outbreak, there were 2 other case definitions that I looked at, and I'll show you those later. One of them was tetanus, and one can conceive that the tetanus actually arose from the interaction of that triad with the agent, host and environment, which put the whole situation into a favourable state for tetanus to occur, and possibly as a result of tail biting or other puncture wounds, that particular animal in that environment, in that place, at that time, incurred the disease. The other cases that I'll show to you later was diagnosed as myoclonia congenita, or jumping or trembling piglets. I'll turn to that later and talk about that later, because there's an original discovery that arose from that particular occurrence in that particular place, in that natural outbreak. So turning here to the first slide. So I divided these first group into 3 subgroups: mild to moderate, moderate to severe, and severe. So in these first 5 cases, there's mild to moderate. These particular animals are showing posterior ataxia. Ataxia means errors in rate, range, direction and force of movement. These animals are showing that. As far as paresis is concerned, that's a type of weakness, and they were showing that as well. Ataxia is on movement. The paresis is, you can see just from standing that they're slightly weak in the hindquarters. And so there's 5 of them to be seen here as examples. Now, one of the methods for a neurological examination is to run a needle along the top line, testing for hyperesthesia, which is evidence of irritability and to some extent pain. So part of my thesis, part of this paper is associated with that aspect of pain. So these animals Most of them are showing hyperesthesia, and later on I'll show you one that wasn't. When I did the pathology, I found that there's myelin degeneration of the brain, spinal cord, and the peripheral nervous system, dorsal root ganglion, trigeminal ganglia. So to me, this hyperesthesia reflects that damage, particularly demyelination, which I found on histopathology. So this is the fourth one of the five. These are the examples of the milder form, what you might call Taufan or Taufan disease. They're all the same virus. There's no reason to suspect that there are different viruses of different virulence in this outbreak. Also isolated the virus initially and then some months later, and they reproduce the disease in the same sort of way. Now this work, which I did as an animal model, proceeds with the hypothesis that this is primarily a demyelinating part of the histopathology that is related to recovery or non-recovery. So at day one, the pig was showing quite severe ataxia. At day 23, it was showing partial recovery, but still ataxia. And day 44, it was completely recovered. To my mind, and my postulation is that remyelination had occurred, and that was one of the aspects. Edema could have been another possibility, resolution, but there wasn't a lot of edema in this disease. It's not well known and not well documented that demyelination is a very significant lesion in this disease, particularly of the dorsal, to some extent, the ventral roots of the dorsal root ganglia. So this is primarily a disease of the peripheral nervous system that is manifested here. This particular aspect is not emphasised in previous reports on Taschen-Taufan disease. In a lot of occasions, they don't talk about the peripheral nervous system. It's true that the neurons, if they're not completely degenerated, might also regenerate over time. But I think myelin and demyelination and remyelination is a very important factor, as it is in things like multiple sclerosis. And so this particular model can be used for those sorts of animal diseases in studying demyelination. And I'll turn to this and other examples a bit later on. So there's pig H. It's still showing hyperesthesia as the other pigs. At day 23, showing some ataxia. And you'll see 44. And as it walks away, it's very difficult to pick up ataxia in that particular pig. It's recovered. We've got to have some reasons as to why it recovered. And when I looked at the histopathology, I found demyelination. And when those pigs come back again, there's no evidence of that. So now we turn to subgroup 2, which is the moderate to severe form, in which the animal is still locomotory, but is showing more severe signs. The appearance of lesions more cranially than posteriorly. In actual fact, what I found in my experiments is that the lesions are distributed rather uniformly along the spinal cord and in the brain, but they don't show the clinical manifestations of it. They quite often show just posterior ataxia, even though lesions are present in the more cranially in the cervical thoracic area. That's an interesting phenomenon. And it might be that the brain has more influence over that particular area. The nerve tracts come further down, and so the brain can control the locomotory movements if they're not so far away as the lumbar. Now, another aspect of 992 is it shows very little reaction to pinpricking, or as some neurologists say, from touch rather than pain, but it shows little or no hyperesthesia, despite the fact that it's got quite severe histological lesions, which I found when I did the histopathology. So that means that in certain cases, the injury can be quite severe, but the reaction to pain or irritability is not. I think that's an interesting finding. 992 here shows that. Now, again, this is another example of the moderate to severe form of this disease. The animal's reluctant to move. Quite often the tail is straightened, indicating paralysis. Predominantly an upper motor neurone disease rather than a lower motor neurone disease. Again, I emphasise that the peripheral nervous system is showing much more manifestation of that than the brain and spinal cord lesions, which are in actual fact present. This is, as you can see, a more severe form. The front legs are still, they can stand on the front legs. The animal is bright, alert, aware of its surroundings, but it's got this more severe. In contrast to Harold, who recovered after 44 days, this next group of 3 pigs did not recover and were not recoverable. So therefore, in my mind, my interpretation is that they're showing the severe form of Teschen disease. As I said before, one of the pigs died, which is the ultimate test of virulence, and a failure to recover and quadriplegia, to my mind, is another example of highly virulent Teschen disease. So these are the examples. They never recovered. Some were there for many weeks, were just lying around, could not get to their feet. They all showed similar reaction to touch or pain. Some people say pain reflex, others say it's touch. Showed hyperesthesia. This one, of course, can see me, there's eyesight reflex. It can see that I'm going to prick it with a needle, so it reacts before I even touched it. Now here's extreme hyperesthesia. Some people might say it's irritability. I take the view that this is a sign of pain. Right down the brain, spinal cord and the peripheral nervous system, there are lesions, particularly demyelinating. It's sporadic, it's not uniform, but it's present throughout the whole of the brain and spinal cord and the peripheral nervous system. And this hyperesthesia may well be a reflection of the demyelination. These animals cannot get up and walk normally. Here's another example showing not extreme hyperesthesia, even though it's got severe lesions. So that bears out what I'm saying about if there's severe demyelination, there may not be a reaction to the pain. The animal can partially right itself. Its head is fairly well orientated to its body. Can relate its head to its body. The distribution of the lesions I found is exactly the same, but the severity at the various locations does vary and a bit more extensive at each location to account for the changes in the nervous signs. So what I'm saying is that those earlier forms still had lesions throughout the brain and spinal cord and the peripheral nervous system, but the intensity was less than in these particular ones. Whereas the literature has in the past said that It's only by accident that the virus gets to the brain and spinal cord and the peripheral nervous system. The truth is that it invariably gets there as a viremia, but its clinical manifestations greatly vary from those more severe forms right down to the milder forms, and also subclinical cases. You can still find lesions, as I'll demonstrate later in my other experiments. So here's a much more severe form, nystagmus, head tremor, and a failure to rise. So now we turn to case definition 2. We looked at the 3 subgroups of the classical Teschen-Talfen type disease, and now we're turning to another case definition. These are known as trembling or jumping piglets. Another name for them is myoclonia congenita. There are only 4. So I developed a hypothesis that the primary etiology or cause is the Teschen virus present in the natural outbreak. And so for the first time in the literature, I'm postulating that this particular virus is producing this disease. It's well known that there's a virus called Smedi virus, which is a Teschen type virus, which produces small pigs, embryonic death and infertility. This particular disease is a demyelinating disease. The other possible causes of this disease are an inherited dysplasia, genetic predisposition, and swine fever, which is not present in Australia, and other viruses which might produce demyelination. Knowing that this is demyelination, and knowing that my virus, as I said just a while ago, produces demyelination, I'm postulating that a part of this disease entity in this natural outbreak is a Smedi type of reaction producing myoclonia congenita. So at this point in time in the literature, it has not been suggested that Teschen virus A can produce myoclonia congenita. This particular pig is showing marked hyperesthesia, which is a trembling type of reaction, as you can see. So what I'm suggesting is that trembling, which is demyelination as well, is comparable to those myoclonia congenita piglets. So here we have this double picture. The top one shows the hyperesthesia, which is trembling type of reaction, which I believe is associated with demyelination. As I said, it's not commonly reported always that demyelination is a feature of Teschen-Talfen disease, but I found it to be so. That's showing demyelination at the top. We know that they're demyelinating below. The virus is Teschen-Talfen disease in this natural outbreak. So I'm postulating that the virus caused this myoclonia congenita and the demyelination. I'm demonstrating that there's a correlation between these 2 case definitions. This is the natural outbreak. This top animal here is showing a trembling type of reaction, similar to this spontaneous one here. This one is at the top is reacting to a soft needle movement, and so underneath there in that spinal cord and peripheral nervous system is injury, demyelination. The other ones already have the injury, and it's much more severe and extensive, so it's more uncontrolled. So what I'm saying is that this virus here, Teschen disease, caused this particular case, and I'm saying that the demyelination associated with this is what is in the literature known as SMEDI virus, which is a Tessin virus, and it's producing the demyelination. Another locomotory disturbance is found here, where the animal is showing nystagmus. See the way the eyes are moving, apart from the flies? But the mouth cannot be prized open, impossible to prise it open, and there is a muscular spasm of all legs. The tentative diagnosis for this will be tetanus. If these legs relax after the injection of this sodium pentobarbital, which I put in, this would confirm to a large degree a diagnosis of tetanus, another locomotory disturbance. So as you can see, the mouth can be opened up now and the legs are flexible. So this is a case of tetanus, which is another diagnostic possibility associated with the range of diseases.